Coming back to our initial equation, just kind of recentering here. So cardiac output, stroke volume times heart rate. And we have talked about all the factors that influence our heart rate because our heart rate is mainly controlled by the SA nodal cells, the autorhythmic cells. Let's look at factors that influence the stroke volume, which is the other variable in our equation. So there are three main factors affecting stroke volume: the ventricular contractility, how vigorous the chambers are contracting; the end diastolic volume, how much blood filled into the ventricles at the end of diastole; and then the afterload. And afterload is pretty much described as the blood that is leaving the ventricle. So what does the afterload look like? What is the amount of blood that's in the peripheral circulation and the pressure in the peripheral circulation look like? And that is going to influence how much blood can effectively leave the ventricle. So first one, the ventricular contractility. And so the more forceful the contractions, which are brought about by the contractile cell, so we're looking at entirely different group of cells here, the more forceful the contractions here, the more blood that will be expelled from the ventricle. And so here we want to think about the sympathetic control only. Going back to what we said earlier, the heart contractile cells do not have any input from the parasympathetic system. So when we speak about ventricular contractility, there's only one division of the autonomic nervous system that can regulate the ventricular contractility. So the sympathetic system innervates the contractile muscle cells. That results in norepinephrine binding to beta-1 receptors, which are also found on these cells. Second messenger is cyclic AMP, and there are 4 results that are brought about on these cells that will help to increase the contractility. The augmenting of the opening of calcium channels, all right? The increase in calcium release from the SR, the increase in the myosin ATPase rate, and then the enhancing of the calcium ATPase activity on the SR as well. So these 4 factors, and we'll describe them in more detail coming up, all help to work towards increasing the contractility of the heart muscle. So let's look at each of these individually. The first one is augmenting the opening of the calcium channels. Now, because we're looking at the contractile cells, here, the ionic movement that results in an action potential is different than the ionic movement for a pacemaker cell. This cell, we talked about the plateau phase, the phase where we intentionally interrupt repolarization in order to allow more calcium to enter the cell. And we describe the fact that cardiac muscle, as well as smooth muscle, are requiring calcium coming from 2 sources: calcium coming from the extracellular fluid, as well as calcium coming from the SR. So augmenting the opening, or stalling, so to speak, the opening of the calcium channels only means that more calcium can get into that cell. It can interact with actin more, and therefore we're going to have more cross-bridging and then more contraction, right? So opening up of calcium channels or keeping them open for longer helps to increase the contractility. The second factor is opening up the calcium channels on the SR, right? Which also makes sense for the same reasons. Because there are 2 sources of calcium here, opening up both of those channels for longer will increase the amount of calcium entering the cell and the amount of contraction. The third one is the myosin ATPase rate. So the myosin heads in the cardiac contractile cells, they have a faster myosin ATPase rate. Therefore, they can increase their speed of contraction and allow for more vigorous contractions in a shorter period of time. So that is a third mechanism by which we can increase the contractility. And then the last and fourth way or mechanism is the increasing in the calcium ATPase pump on the SR. So this is how we pump more calcium back into the SR. which is important for ceasing the muscle contraction. So if we can get more calcium back into the SR faster, the muscle can relax faster. And we made this connection before. If the muscle can relax faster, it can contract faster. So speeding up the rate of our myosin ATPase activity on the myosin heads and the calcium ATPase activity on the SR means that we can increase the rate of contraction as well. Okay, so just illustrating the difference there, if we have X amount of tension in a specific time at rest with no external influence, this is the contractile cells, and they can generate this amount of tension at rest, right? This is the black curve. If we had increase in sympathetic activity, we can generate even more force in a shorter amount of time. So speeding up those four mechanisms that we just described on the contractile cells means that in less time, we can generate more contraction, more force of those cells under sympathetic influence. Okay, now just to remind ourselves and reiterate here, contractility has no input from the parasympathetic nervous system. There is little to no influence coming from the vagus nerve that, that affects the actual contractile cells. It is mainly the sympathetic nervous system that can affect how hard those contractile cells are working. And then if we think about the hormones that affect contractility, it's going to be the same as we said earlier. Epinephrine, whether it's a neurotransmitter or a hormone, same effect on the beta-1 cells. That's going to bring about those four different mechanisms we talked about, and that will result in increased contraction. We also want to look at some other hormones that could affect the contractility. So the thyroid hormone, and we know thyroid hormone is a metabolic hormone, so it would make sense for T3, T4 to increase contractility. Insulin and glucagon can also increase the contractions as well. All right, let's look at the end diastolic volume. So the end diastolic volume is the second factor that we said can increase stroke volume. And just to kind of recenter what we're describing, we are talking about stroke volume, the individual factors that influence stroke volume, and we mentioned three of those. So increased contractility, increased end diastolic volume, and increased afterload. So now we're getting into the second factor that affects stroke volume, which is the end diastolic volume. So if we can fill more blood into the ventricle, we can eject more blood from that ventricle. And that is the basic principle of Starling's law. So Starling's law says that if we increase the stretch of our cardiac muscle fibers, we're going to bring those fibers closer to their optimal length. And if we bring them closer to their optimal length, we're going to have more cross-bridge cycling, and we're going to have more strength of contractions or more tension or more force for those contractions. So if we increase our end diastolic volume, we result in an increase in our stroke volume as well. Okay, and I just want to remind ourselves of the optimal length. This is something that we described for skeletal muscle when we were looking at skeletal muscle, the factors that affect force generation for skeletal muscle. We said that whenever the fibers are closer to their optimal length, they're going to generate more force. For skeletal muscle, that is going to be in the middle. So the sarcomere, if it's too stretched out, we decrease the force generation. If it's too contracted, we decrease the force generation. And for skeletal muscle, the optimal length is somewhere right in the middle, that nice happy medium. For cardiac muscle, it's different. The more we stretch, the more we approach the optimal length. Therefore, stretching more results in more force generation in cardiac muscle. All right, so we can increase the venous return, the amount of blood that's coming back into the heart by way of filling from the atria down into the ventricle. We will therefore stretch the heart out more, and that's going to help our fibers get to their optimal length. And so we're going to increase the force of contraction and therefore increase our stroke volume. All right, so just illustrating that here's our stroke volume, here's our end diastolic volume. Here is our sarcomere length, right? So here's our sarcomere length when it's relaxed. And then here's our sarcomere length when it's stretched out and approaching its optimal length. Notice that the stroke volume and the end diastolic volume are both lesser, right, or a smaller amount, a smaller volume when the fibers are relaxed. So when the heart is relaxed and it's not stretched out, those sarcomeres are not stretched, we generate less filling by stretching less. So our end diastolic volume is lower, and then we generate less stroke volume by ejecting less, and so our stroke volume will also be lower. If we can stretch that sarcomere out more by filling more volume, we have a higher end diastolic volume, and therefore we have a higher ejection, so we have a higher stroke volume. All right. Another way to illustrate that, if you look at the initial curve here, so this is basically our stroke volume and our end diastolic volume at rest in this green in the middle here. If we increase sympathetic activity, we are going to have an increase in the end diastolic volume, and then we're going to have an increase in our stroke volume. Likewise, if we decrease sympathetic activity, we're going to have a decrease for both of those volumes as well. Okay, the last factor was the afterload, and the afterload, we said, is the pressure in the aorta. So the pressure that is in the vessels that are leaving the ventricles. And if we think about it, it's like a hose. If you have a blockage in your hose, then it doesn't matter how much blood is leaving the tap, there's going to be a blockage, right? So it's going to be less blood leaving overall, regardless of the force of contractility. Same with our afterload. Afterload is basically how much pressure exists in the aorta being the main vessel that we look at, and that will determine how much blood can effectively leave the ventricles given the amount of resistance that blood has to face in the peripheral vasculature. Preload, on the other end, is what's coming into the heart. So afterload is what's leaving, preload is what's coming in. So preload is going to influence the end diastolic pressure, how much blood and how much pressure is the atria filling, and therefore how much of that is spilling down into the ventricle. That's gonna result in our affecting our filling time. It's going to affect the atrial pressure, and then as well as the central venous pressure. So if we look at our major veins like our superior vena cava, our inferior vena cava, what kind of pressure exists in those veins will also determine how much blood is going to be filled into our atria and subsequently ventricle, versus the afterload being how much pressure exists beyond the ventricles. All right. Now, this last illustration here is just showing how all of these factors influence stroke volume. So increased venous return, increase of blood coming back to our atria and then subsequently our ventricles. This will increase our end diastolic volume, therefore it will increase our stroke volume. Increase in sympathetic activity or epinephrine as a hormone. That will also increase our strength of contractility by the 4 mechanisms we described, and so that will also increase stroke volume. Lastly, increase in the arterial pressure decrease, this one is the opposite, decrease in our arterial pressure, otherwise known as our afterload, will make it easier for blood to leave the ventricle because it's less resistance, and so that will likewise increase stroke volume. All right. Okay. Any questions? Any questions at this point? Any questions? Now, we don't have enough time for sure to get into a review, but please look at the videos that I'm going to share right now. I'm going to try to post them right away, and they will be available to review some of the major concepts for the exam. And then again, as I mentioned, I set a set of practice questions that will help you review the major concepts from each module in preparation for the final. All right. So look out for those resources that I'll be sharing on Brightspace. If there are not any questions on this, we're going to look at one practice question, and then we will call it a day.